Hello, algebra. Let's continue lesson 2.5, solving compound inequalities. We're going to start with the ands because they're a little bit more complicated. So we're looking here at -4 is less than x minus 2, and it's less than 3. So this is an and, right? It's a compound inequality. It's got and in there. Here's what I want you to do. When you go to solve these, the easiest thing to do is to separate them out, all right? So I am just going to cover up one side and write that inequality and solve it like we would normally. So we would have -4 is less than x minus 2, right? I just covered up my less than 3, rewrote it. I'm going to solve that one. I'm also going to cover up the -4 here, and I'm going to rewrite this one. So x minus 2 is less than 3. And I'm basically going to treat it like two separate inequalities, all right? That way I don't accidentally mess something up. So if I want to solve this guy over here, I need to add 2 on both sides. Well, that means I've got -4 plus 2 is a -2. My symbol stays, and I have my x. And on this side, I need to add 2 as well to both sides. And so we are left with an x, and it's less than 5. So now I can go to graph this. This is really -2 is less than x, and x is less than 5. You could recombine these into one compound inequality. So that'd be -2 is less than x, which is less than 5. And then when I go to graph it, -2, -1, 0, 1, 2, 3, 4, and 5. I'm going to do an open dot here, and I shade. This is where it gets tricky, remember? So sometimes it helps to rewrite this so that you have the x is greater than -2, because this points the direction you shade, not here. So I'm going to shade to the right, to the greater than side. And then for 5, I do an open dot. Do I shade it in? No, and I'm shading to the x is less than side. So you can leave it like this. You can rewrite it into a single compound inequality either way, and here is our graph. Please email me if you have questions. Let's check out the bottom one here. So again, I'm going to separate these out. I'm just going to cover up this side, right? So I've got -3 is less than -2x plus 1. And then I'm going to cover up this side. So -2x plus 1 is less than or equal to 9. And I'm just going to solve them separately. So looking at my left-hand side here, to get x by itself, the first thing I do is to subtract 1 on both sides. That's the opposite of add. So we have -4 is less than -2x. And then I need to get my x by itself, so I have to divide by -2. Divide by -2. Be very careful. Warning, warning, warning. I just divided by a negative. All right, that means that my inequality symbol has to flip around. So it becomes a +2, which is less than x. Or x is less than +2. Better way of saying it. So I'm going to rewrite that so I have an x is less than 2. All right, on this side now, we are going to subtract 1 from both sides. So we have -2x is less than 8. And then I need to divide by my -2. Warning, warning, warning. I just divided by that negative again, that pesky negative. So that means my inequality symbol flips around, and I get x is greater than, in this case, -4, right? Positive divided by negative is negative. So my final answer is going to be x is less than 2, and x is greater than -4. Now you can combine these into one inequality because it's an and. So that means that we would have x in the middle. We would have it greater than 2. Greater than -4. Dyslexia kicked in there. And less than 2, right? X is less than 2, greater than -4. And then when I go to graph this, I've got -4, -2, 0, and 2. I do an open dot my -4. Do I fill it in? Nope, it stays open, and I am shading to where x is greater. And then I've got an open dot at 2. Do I fill it in? Nope, and I am shading to where x is less. All right, so there we go. Those are our answers. I want you to try the next 2. Okay, pause the video here, try these 2 on your own, and then check my notes key for the solutions. All right. Let's take a look at solving OR inequalities now. OR inequalities. With this one, what's nice about it is it's already been separated. So when you go to write your answer, you're writing it just as, together. There's no separating needing. All we have to do is just solve them as they are, which is kind of nice. Let's focus on the left side first because we start by reading left to right. Sorry guys, my tongue is very twisted today. So I'm going to add 5 on both sides to start with. We are left with a 3y is less than negative 3. And then I want to get y by itself. I need to divide by 3. So y is less than negative 1. Was this a positive or negative? Positive. So do I need to flip this? Nope, my inequality symbol stays the same. So it is fine. So that is one side. I'm just going to drop this OR right down. So I'm just going to write it so I remember that it's an OR. And then on this side, we have 2y minus 1 plus, or is greater than 5. So I need to add 1 on both sides, which means I have 2y is greater than 6. And then I need to divide by 2 on both sides. So I have y is greater than 3. Now be careful, was this a positive or negative? Positive. So I need to flip my inequality symbol? No. So this is my answer. Y is less than negative 1 or y is greater than 3. I'm going to do my negative 1, 0, 1, 2, and 3, my number line. I start with my y is less than negative 1. I do an open dot, and I am shading to the left, to the less than side. And then I do my 3. It's an open. Do I close it? Nope. And then I shade to my 8. All right, let's do this one next. Remember, I'm going to solve each side separately. So I am going to subtract 3 on both sides here. I leave my inequality symbol. Remember, we only flip it when it's multiplying or dividing by a negative. And then on this side, we've got a negative 8. I need to divide both sides by 4. Hey, that's a positive number, so I just need to leave it as it is. So we have a c is less than or equal to negative 2. Remember, it's only when we multiply or divide by a negative that we switch our inequality symbol. Bring down my OR, and then on this side, to get c by itself, I need to add 8 on both sides. So we have a c is greater than 7. So our final answer is going to be c is less than or equal to negative 2, or c is greater than 7. When I go to graph that, I've got my negative 2 down here. 0, 2, 4, 6, and 8. I'm going to do a little guy in there for 7. 5, 3, 1, negative 1. I do an open dot for 7. I'm shading to the greater side, which is to the right. I do a closed dot for negative 2, and I shade to the left. There are 2 more problems on the next page. I want you to take a minute to try them out, graph them, see what you get. Remember, when you see parentheses, make sure you distribute that. Just so I have said that now, make sure you distribute that. All right, last thing we're going to do today is a quick word problem. All right, electrical devices should operate within a specific temperature range. Outside of that operating temperature range, the device will fail. All right, we're going to write and solve a compound inequality that represents the possible operating ranges in degrees Fahrenheit of own.